G'day, Michael here. I've been asked about cutting threads and printing threads in 3D printed parts. Now these bearing assemblies, all the threads that I have there, including the 5mm thread that's holding the bearings themselves, the 3mm thread that's holding the ball socket, and these are working parts, and also that the end stop that you can see sliding up and down. All those parts are threaded directly into plastic. Now on the print head as well, those threads are all in the 3D printed parts. Now it's important to leave plenty of extra material, so just make the holes well and truly undersized to leave enough material to cut, and also make sure there's enough wall thickness, perimeter thickness in all the parts, so that where you're driving a thread into, that there's plenty of material to hold it all together. And you've got to think about where the stresses are applied as you're doing the design. But basically, if you ask for sort of a couple of millimetres of perimeter, now the reason why I say millimetres is because that may be 4 passes on a small tip, or it might be just 2 passes on a large tip. These small parts here, I think I had, from memory, 4 perimeters, but it was on a fine tip, a 0.4mm tip. And naturally, something done with this large 0.8mm tip only needs a couple of perimeters. Now I'll just show you some parts that I've cut threads in. Now these parts have not got their threads cut in them yet, but of course here's the end result, and they've got a 12mm thread. This is an M12 stainless steel thread, and let me just hold it in such a way you can see it. The threads function beautifully, and I just dropped the part. The threads actually function absolutely beautifully, and there's plenty of strength in them. I've had no problem with thread stripping. But there is a proviso on that. The threads actually have to be cut cleanly. I find the easiest thing to use is just even a spray and wipe bottle with some water in it, you know, window cleaner type stuff. And I just spray that in the plastic. And it's important to use the focus. The tap has to be quite a sharp tap. Now this is an M12, a metric 12mm tap. Let's just see if I can get that to rotate. Okay, can we see that? Let's see that, it's high speed steel, 12 by 1.75. So that 1.75, I guess divide that by the square root of 3, yep, so the square root of 3. So it'll be about 1mm depth in that thread. So in other words, the hole would have to be 2mm undersized for you to get a proper amount of material. Now I found I don't have to actually be that critical, so long as it's reasonably deep in the cut. So the thread's cut really nicely. As you can see, these edges are nice and sharp. Some of the carbon steel taps aren't sharp enough to do the job properly, and you end up with a very furry cut. Now here is, let's see if I can hold it at an angle that you can see something. Forgive me for this shaking. Can you see that thread? Focus. There's a 3mm thread cut in that. I don't know whether that shows up in the video. I'm hoping it does. Show better there maybe. Where are we? Oh yeah, I think you can just see the thread there. That's a tiny thread. That's an M3 thread. But again, it has to be a high-speed steel tap. Very important. Don't try to use anything that's blunt. You need a sharp tap to cut the threads properly. Focus. So you can see here on this template assembly, these threads work, really quite nicely, and I get beautiful operation. People ask whether you can print threads. Well, I actually haven't had any luck printing threads, even large threads. So I'm not the guy to ask. I have not had a good success with printing threads, but I certainly had very good results with cutting sharply cut tapped threads into the material by leaving enough body to tap into. Anyhow, I mean, it's not much of a video, but I hope that answers a couple of questions. Well, that's it from me. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.